So guiding factors for choice of number of armature slots. First guidelines, for larger machine, slot pitch varies between 25 to 35 mm, and for smaller machine it can be less than or equal to 20 mm. So the mathematical governing equations based on your slot pitch should be pi d by SA. So pi is nothing but a numerical value, and d is your diameter, armature diameter, and SA is your armature slot. So this is your slot pitch y, SA equal to pi d by SA. And second guideline should be slot loading or number of ampere conductors per slot should not exceed 1500 ampere. So mathematically your slot loading should be your current times of number of conductors, Iz times of Zs. And third guidelines, the number of slots per pole pair should be an odd integer to minimize the flux pulsation losses. In general, number of slots per pole should be S by P. This is the case when we have lap winding. We have to add the parameter plus or minus 1 by 2. Integer, the selected integer value 9 or 10 plus or minus half for lap winding. In case of your wave winding, number of slots per pole arc is integer plus half. So in large machine, the slots per pole should be at least 9 per. So நம்ம generally வந்து problem solve பண்ணும்போது we are using the value 9, at least 9, in order to prevent commutation. For better commutation, the number of slots per pole should be 9 to 16. For smaller machine, we may take 8. And fifth guideline should be the number of slots must be suitable for number of coils and number of coil sides per slot. So less than 5 kilowatts means we have to utilize 8. 5 to 50 means 10. Above 50 means we have to use 12 or more. So the following factors should be considered. Selection of slot should be DC machine winding is double layer, and the number of conductors should be per slot should be an even integer, and the number of conductors per slot should be divisible by the number of coil sides per slot to get number of turns per coil as an integer. I'll show while solving the problem. What does that mean? For simplex lap windings, the number of slots should be in multiple pole pairs for providing equalizer connections. In case of simplex wave wound machines, the number of slots should not be a multiple of pole pairs. The slot should be an odd number, and to avoid dummy coils, slot per pole arc should be an even number that lies between 8 to 16. So the slots per pole arc should be your side times of slots per pole. And then your armature conductors, cross section area of the armature conductors, IA is PA into 10 cube by E. We know that the armature current is IL plus IF for the case of generator. For the case of motor, it is IL minus IF. So we know that IA stands for armature current, IF stands for field current, and area of each conductor AZ is nothing but your conductor's current by your current density. So the IZ is nothing but IA by 2 for wave winding machine, and Iz equal to Ia by P for lap wound machines. So the main purpose of current density, sixth factor. So the reduced cross section area, and it leads to economy in the cost of copper. So the main intention while using your current density is it reduces the copper, and then it leads to your higher copper losses, higher temperature rise, and lower efficiency due to high current density in a conductor. Based on the requirements, your daily current density should be 4.5 amps per mm square for large strip wound armature with a good normal ventilation. In case of 5 amps per mm square for small wire wound armature with very good normal ventilation, and the case of 6 to 7 amps per mm square for high speed fan ventilated machines. So up to 19 mm, the frequency is less than 25 Hz in order to avoid your eddy current losses. And up to 15 mm, the frequency is more than 25 Hz. And slot dimensions, those dimensions of the slots, it depends upon your width, depth, or height. So the following factors should be considered for your slot dimensions. So number one is reactance voltage, eddy current loss, width of the slot, flux density, and mechanical difficulties. So based on the diameter, you have the slot depth or height. So 0.15, 22.5, 0.2, 27.5. Like that we have up to the 0.5 values. So armature voltage drop should be IARA. So RA should be Z by 2 rho LMT A square AZ in ohms. So rho, you know the resistivity of copper for cold conditions and 50 degrees Celsius. The values is mentioned. And Z is number of armature conductors, LMT length of mean turn of armature conductors. So mathematically LMT is 2L 2.3 tau plus 5 ds. So we know the tau value pi d by p. ds is nothing but depth of the slot. So the depth of the armature core is phi c equal to 5 d by 2, and flux density in the armature core is 5 by 2 by cross section area of the armature core. So 5 by 2 divided by dc into li. Cross section is dc into li. DC is depth of the armature core 1 by 2 5 by Li BC. So this BC varies in the range of 1 to 1.5 Weber per meter square. In normal working condition, we are choosing 1.25 Weber per meter square. So these are all the 9 selecting guidelines for design your armature. So while you seeing your guidelines, it is not understandable, but while you solving with a numerical example or real-time example, it is easier to understand. So just listen what I am trying to teach in the problem. So this is one of the famous questions which is repeatedly asked in your university examination. So determine the diameter and length of armature core for a 55 kilowatt 110 volt 1000 rpm 4-pole shunt generator, assuming the specific electric and magnetic loadings as 26,000 ampere conductors per meter and 0.5 Weber per meter square respectively. The pole arc should be about 70% of pole pitch and length of core about 1.1 times of pole arc. Allow 10 ampere for field current and assume a voltage drop of 4 volt for the armature circuit. Specify the windings used. Also determine the suitable values for the number of armature conductors and number of slots. So these are all the things which was given in the problem. It is a 55 kilowatt, 110 volt, 1000 rpm 4-pole shunt generator. The loadings is given and pole arc to pole pitch ratio and length to breadth ratio and your field current value, IA, RA drop, everything is given. So these are all the given things. Your power should be 55, voltage should be 110, speed should be 1000, pole should be 4, AC should be 26,000, BAV is 0.5 and pole arc to pole pitch ratio is 70%, so 0.7 and length equal to 1.1 times of your bore width, that is B. Field current is 10 amps, IARA drop is 4 volts. So we have to find out first one main dimensions D and L and specify the winding, what type of winding it is, whether it is lap wound machine or wave wound machine. So the winding we have to specify. And third one is number of armature conductors Z, and last one is number of armature slots. So these 4 parameters we are going to discuss in the design of armature problems. So first one we have to calculate our main dimensions, whatever we are discussed in your first one, that is first 1 to 6 problems. So we know that PA equal to C naught D square L N in kilowatts. And also we write PA as EIA into 10 power minus 3 in kilowatts. So we know that generated EMF for generator is V plus IARA. V is given, IARA is also given. So 114 volts. And then your armature current should be IL plus IF. And your P equal to VIL we know. So based on this expression, we are easily find out what is IL. So 55 kilowatt volt is 110 IL. So 55 into 10 cube divided by 110, you may get power in kilowatts. Sorry, IL in amps. So IL is 500 amps. So once you find out your IL, IA equal to IL plus IF. So IF is given in the problem 10 amps, 500 plus 10, 510. So IA equal to 510. So PA equal to EIA into 10 power minus 3. 114 into 510 into 10 power minus 3. You may get 58.14 kilowatts. So then we can easily find out our C naught. C naught is pi square BAV AC into 10 power 3. Pi square we know, BAV is 0.5, AC is 26,000 into 10 power 3. You may get 128.3. சரியா? அடுத்தது speed in RPS 1000 RPM is given divided by 60, you may get speed in RPS 16.67. So once you find out n, c naught, everything, you can directly determine what is the value for your d square L n. So d square L. So PA equal to c naught d square L n. So PA is 58.14, c naught is 128.3, d square L into 16.67. So once you are solving, you may get d square L as 0.02718. So these things we are already discussed in selection of poles as well as your basic problems. So only it doesn't give time to solve. But after this step, you have time to solve what type of values you have. So d square L, the calculation of L and d is, it is familiar to us. So L is 1.1 times of b. So 1.1 into your b is nothing but 0.7 times of tau, because b by tau equal to 0.7. So 0.7 times of tau, where tau is nothing but pi d by p. So number of poles is given as 4. So once you're solving 1.1 into 0.7 into pi by 4 is nothing but 0.6047 d. So substitute this L value in d square L expression. So once you are solving, you may get d square 0.6047 d equal to 0.02718. D cube you may get 0.0449. Once you are taking cube root, you may get d. So once d value is easily find, means we just substitute the value of d in L. So if you are substituting in L, you may get L as 0.215 meter. So இது வந்து நம்மளுக்கு எல்லாருக்குமே ஃபெமிலியரா தெரிஞ்ச ஸ்டெப்ஸ். இது நம்ம கிட்டத்தட்ட ஒரு 7 to 8 ப்ராப்ளம்ஸ் போட்டது எல்லாமே இது இந்த மெத்தட் தான். சரியா? இது வந்து ஃபர்ஸ்ட் அந்த சப்டிவிஷன் ஓவர். We are just to find out your main dimensions D and L, armature core and armature length, ரெண்டுத்தையும் நம்ம வந்து கண்டுபிடிச்சிட்டோம். So next one is specification of the winding. So specification of the winding means the current per parallel path should not exceed 200 amps and the current per brush arm should not exceed your 400 amps. So this is the guidelines which we have in your selection of poles. நம்ம நேத்து நம்ம பார்த்தோம் இல்லையா, அந்த மெத்தட்ல வந்தது. So for wave winding, current per parallel path is armature current by 2. So armature current we have 510. So 510 by 2, 215. So the wave winding, it is not satisfied. For the case of lap winding, IA by P. So 510 by 4, 127.5, which is less than 200. So this current per parallel path is satisfied. So next one is current per brush arm, 2 IA by P, 2 into 510 by 4. Excuse me. It is less than 400, 255 amps. So the current per parallel brush path, the current per parallel path as well as current per brush arms, both are satisfied. It is less than 200, it is less than 400. So the machine should be, definitely it is a lap wound machine. So you have to write conclusion as the armature winding specified as lap wound machine. It is not wave wound, it is a lap wound machine. So in the case of problems, you have to specify the windings, means you have to use this condition. The current per parallel path should not exceed 200 and current per brush arm should not exceed 400 amps. So you may get the separately specify what type of winding it is in your 1 mark or 2 mark also. So remember this conditions, how to get your lap wound or wave wound, whether it is satisfied or not. So this is the structural procedure. Next one is they are asking what is the number of conductors Z. So in general, for generator E equal to pi Z NP by A. You know all the parameters, pi Z NP A எல்லாமே தெரியும். So based on this equation, we are getting Z. We need only Z. So EA by pi NP. So for lap winding machine, your number of poles equal to number of parallel paths. A equal to P. I hope it is clear to everyone. For lap wound, it is A equal to P. So I am assuming AP as same 4. And then specific magnetic loading, BAV is P5 by pi dl. So from this expression, we may get our flux. So phi equal to BAV pi dl by P. We know all the values. BAV phi is mentioned, pi value, D value we are determined, L value we are determined, and P is number of poles. So once you are substituting, you may get pi as 0.0299 Weber. So now you know all the values. Substitute all the values in that equation. EA by phi NP. So AP get cancelled. E by pi n. Correct? So 114 by 0.0299 into 16.67. So what do you get? 114 divided by 0.0299 into 16.67. So I am getting 228.7. உங்களுக்கு என்ன கிடைக்குது? The armature conductors I am getting as 228.7. So I am approximating to 228 because we doesn't consider 229 value. It is odd. So even number of conductors only have, because it is pole pairs. So even la irundha dhaan unakku pole pairs varum, odd la irundha pole pairs varadu. அதனால வந்து I am taking 228.7 வந்தது. So I am rounding off to 228. சரியா? இது வந்து third subdivision over. Next வந்து பாத்தீங்கன்னா number of armature slots SA. So we know that your slot pitch, the slot pitch variation should be 25 to 35 mm. So ISA equal to pi d by SA. It is your first guideline or second guideline. Pi d by SA. So from this equation I am getting SA. SA equal to pi d by YSA. So first I am substituting my first limit, that is YSA equal to 25 mm. What is your number of slots? So pi into 0.355 divided by 25. So I am getting 44.6. So approximate to 45. So number of slots. So next one is I am applying the higher limit, that is YSA equal to 35 means I am getting 31.86. I am rounding off to 32. So the number of armature slots within the range of 32 to 45. ஏன்னா நம்மளுக்கு வந்து 25 to 35 தான் ரேஞ்ச் இருக்குன்னு போட்டிருக்காங்க. ஸோ உங்களுக்கு கிடைச்சிருக்கு 35ல 32 கிடைச்சிருக்கு, 25ல 45 கிடைச்சிருக்கு. So the slots lies between the range of 32 to 45. So it should be in your even number because it is a pole pair. So 32, 34, 36, 38, 40, 42, 44. We have to choose the number of choice of the armature slots in this manner. The range should be 32 to 45. So it should be the even number, the armature slots. So I am taking in this manner. So from this range 32, 34, 36, 38, 40, 42, 44, I have to choose which one is suitable to me, or which one is suitable for the design. So to reduce the flux pulsation, the slots per pole should be an odd integer plus or minus half. So in general, while discussing our guidelines, you may take 9 as the value in order to prevent the commutation. So 9 plus or minus half. So number of slots per pole should be 9 plus or minus half, either 8.5 or 9.5. So for our convenience, we are taking highest value, 9.5. So 9.5. So number of slots should be, slots per pole is 9.5 and number of pole is 4. So SA should be 38. So within this range, 38 is my desired one. So I have to use number of choice of allowable armature slots is 38. Okay, wow. So இப்போ 4 subdivisions முடிஞ்சிடுச்சுப்பா. அடுத்து வந்து பார்த்தீங்கன்னா இவர் conductor per slot, armature conductors per slot வந்து we are the designed values 38 is one of the allowable choice. So what is the armature conductors per slot? So is nothing but ZS equal to Z by SA. So Z we are determined 228, SA we are determined 38. So 6 conductors per slot. For while designing your armature winding, you have to fix 6 conductors per slot. And the next one is we have to choose our minimum number of coils also. Once you are fixing your conductors per slot, how much quantity of the coils is needed. So the conductor should be even. For double layer winding, the conductors per slot should be an even. So the minimum number of coils relation we have is C minimum equal to EP by 15. EP is your EMF. 114, poles is 4, minimum is a constant. So 114 into 4 by 15, you may get 30. So next one is I have to choose my number of coils. Which one is suitable to us? That is C equal to 1 by 2 U into SA. So U we have to fix 2, 4, 6, 8, 10 like that we have to fix. Here the number of conductors should be only slot should be 38. So I am fixing U equal to 2. I may get number of coils as 1 by 2 times of 2 into 30, 38. So 38. Next one is U equal to 4. So C equal to 1 by 2 into 4 into 38. I may get 76. So now you have two number of coils, either 38 or 76. So we have to fix whether we need 38 or 76. So அதுக்கு ஒரு டேபிள் இருக்குப்பா. என்ன டேபிள் அப்படின்னு பார்த்தீங்கன்னா my conductor per slot is ZS and coil sides per slot is U. So first case I am getting my number of conductors per slot is 6. So போன கேஸ்ல கண்டுபிடிச்சிருக்கோம் 6 slot இல்லையா 6 by U. First case நம்ம U எடுத்தது வந்து 2. So 6 by 2 வந்து divisible. கரெக்டா 3 வரும். But 6 by 4 is a fraction. So எந்த conductor by U வந்து divisible ஆகுதோ that case we have to choose. Fraction வரத omit பண்ணிடணும். So இங்க பாருங்க. So U equal to 2 is the acceptable limit of number of coils. Therefore the best choice of coil C equal to 38. So it is a fraction. We are just neglecting the second case. So number of turns per coil. Or turn coil எவ்வளவு வேணும் அப்படின்னா Z by 2C. 228 by 2 into 38, that is 3. 3 turns per coil. So 38 காயிலுக்கு ஒரு காயிலுடைய இதுக்கு 3 turns இருக்கணும். சரியா? So then only your design should be in a good manner. So once you find out all the values, substitute in the result. That is armature diameter D equal to 0.355 meter, L equal to 0.215 meter, and lap winding machine. The nature of winding is lap, and armature conductors is 228, and number of armature slots is 38. சரியா?